Let's work through this gateway exam. And I want to emphasize places where people had trouble. What were common kinds of mistakes? So the first problem is, y is the cube root of t to the fourth minus t cubed plus 2t. First thing, you would definitely want to do this is you'd want to write this as a power. You'd want to write it as t to the fourth minus t cubed plus 2t to the 1/3 power. Okay. Few people didn't do that. Most of you did that. Few people didn't. That's the very first thing to do. Now we find the derivative based on that. And we need, I hope you see, the chain rule because we have an inside function, t to the fourth minus t cubed plus 2t. When you plug a number in for t, that expression gets evaluated first. And then after you've done that, you raise to the 1/3 power. So the outside function is effectively x to the 1/3 power, or t to the 1/3 power if you prefer. The derivative of that is 1/3 x to the negative 2/3, right? Because 1/3 minus 1 is negative 2/3. But stop there. Don't just write t to the negative 2/3 or x to the negative 2/3. You need to plug in the entire inside function into that derivative. T to the fourth minus t cubed plus 2t all needs to get raised to the negative 2/3 power. Then multiply times the derivative of the inside. And here's where the most common mistake is. You're multiplying by that entire derivative. You have to have parentheses here. Absolute must. The derivative of t to the fourth minus t cubed plus 2t is 4t cubed minus 3t squared plus 2. The most common mistake was people didn't put parentheses here. The reason that's so important is if you don't have parentheses, the implication by order of operations in math is that you'd be multiplying this just by 4t cubed, not by the entire thing. We're multiplying this by the entire thing. You have to have the parentheses. That was the most common mistake. Next problem. This is a product of two functions. The quickest way to do this is with the product rule. We have a left function, x plus 1, and a right function, secant of x. Left, d right, I need the derivative of secant of x, which can be memorized to be secant of x times tangent of x. So that's left d right, the left function times the derivative of the right function, plus right secant of x, d left, the derivative of x plus 1 is just 1. That's it. You're done. If you've got the derivative of secant memorized. I did give you a hint that if you don't have the derivative of secant memorized, you could derive it. You could think of secant as 1 over cosine of x. But that led to some trouble for some people because when they took the derivative of 1 over cosine of x, they did it wrong. 1 over cosine of x is a quotient. So you need the quotient rule for that part if you want to do it this way. In fact, you could think of the entire thing, x plus 1 times secant of x, as itself a quotient and differentiate this, if you prefer, with the quotient rule as an alternative way to do it. But with the quotient rule, you got to get the order on the top right. Low d high minus high d low, not the other way around, which was another common mistake. Start with the low function, low d high, the derivative of the top is just 1, minus high d low, the derivative of cosine is negative sine x, and you'd want to use parentheses here. Technically, well, okay. Technically, if you don't use parentheses here, it's okay as long as the dot is there as well, times negative sine x. Parentheses missing would be okay. But if the parentheses are gone and there's no dot, that would be a problem because that would imply x plus 1 minus sine x, and that's not what you're doing. You're multiplying times the opposite of sine x, not subtracting sine x. There's, again, low d high minus high d low over the square of what's below, cos of x quantity squared, which, yes, traditionally is written like that. These answers are the same. They may not look the same, but they are. This part of the fraction, cos x over cos squared x, is by simplification the same as 1 over cos x, which is secant of x. So that part just matches that. And this part over here matches this part over here. The two minus signs would cancel to give you a plus sign. There you see the x plus 1. And yes, sine over cos squared is secant times tangent, because this is 1 over cosine and this is sine over cosine. Multiply them, you get a sine over cos squared. Same thing. Many people wrote the derivative of this, though, as 1 over negative sine x. No. Have to use the quotient rule. The most common mistake in number 3. Well, there are a few common mistakes. On number 3, sometimes people got the top of the quotient rule wrong. Remember, you want to start with the low function. Low d high minus high d low. Low, use parentheses. It's the sum of two things. So sometimes people forgot parentheses there. Low d high, derivative of sine 2x. I need the chain rule for it. Get cos 2x times 2. There's no parentheses around the 2x there, which is technically okay, standard notation. It doesn't hurt and maybe is helpful to put parentheses around it. If you put cos 2x times 2, you really should have parentheses around the 2x there, because it's order of operations. You're doing 2x first before cosine and then multiply by 2. If you don't have parentheses there, the implication is kind of like do 2x times 2 first, then take the cosine, which is not what this is. This is cosine of 2x, then multiply by 2. That's low d high minus high d low. The derivative of 4 is 0, so you can get away with not having parentheses here, because the derivative of 4 is 0. The derivative of natural log of 3x with the chain rule is 1 over 3x times 3, right? The derivative of natural log of x is 1 over x. But we have a 3x in there, so we need a 1 over 3x times 3. Though you can leave it like that, but something interesting does happen. You can cancel those 3's, and you're left with just 1 over x. When simplified, that might seem a little strange, until you remember that natural log of 3x by a property of logs is the same as natural log of 3 plus natural log of x. That's why the derivative of natural log of 3x is really the same as the derivative of natural log of x, just 1 over x, if you happen to cancel the 3's. But you don't have to cancel the 3's. Over the bottom squared. So take this entire thing and square it, use parentheses there. You're squaring the whole thing. If you were going to expand this out, you'd have to FOIL it. The answer, if you expanded this out, would not be 16 plus this thing squared. There'd also be a plus 8 ln of 3x from the outside and inside terms of FOIL. You know, I think what's coming back to haunt many people here when they do things like this gateway is just really arithmetic and algebra, things that you don't really remember thoroughly or understand thoroughly from your past, okay? And that's hindering you. Order of operations, not realizing you need parentheses because of order of operations. All those kinds of things that you got confused about in your past and are still feeling confused about today are causing problems on the gateway. Not doing well in the gateway ultimately, or in the class ultimately, can lead to problems in future classes. I mentioned this the other day. You know, you're in a mechanics class, your teacher takes the derivative of something complicated, you have no idea what's going on. You want to know what's going on. You want to be able to reproduce it for your own benefit and understanding. 4, tangent of x plus 1 over x minus 1. That's not an inverse tangent, it's tangent. One mistake was people treated this as if it was an inverse tangent. No, it's tangent. So the derivative of tangent is secant squared, memorized. I need the chain rule. There's my inside function. Derivative of tangent is secant squared, but then plug in the inside function. Then multiply times the derivative of the inside function, which you need the quotient rule for because it's a quotient. low d high minus high d low over the square of what's below. Stop right there. You don't need to simplify. Some people tried simplifying, they made a mistake. If you did simplify this top part, it would simplify to x minus 1 minus x minus 1, and the x's would cancel. It actually simplifies to just a plain -2. So it's a benefit to not simplify. Leave it like that. Number 5, differentiate 4 times e to the 3x plus 1. It's a chain rule problem. Inside function is 3x plus 1. The derivative of e to the x is e to the x. The derivative of 4e to the x is 4e to the x. So you start writing that, but then you got to plug in the inside function, 3x plus 1, times the derivative of the inside function, 3. That's the derivative of that thing right there. You're done with that part. Some people sometimes, I saw mistakes like they forgot to put the plus 1 there, or they put like an extra factor of e in here. No. This is how you do it with the chain rule. This is 2 times the derivative of inverse sine, which is just memorized to be 1 over square root of 1 minus x squared, but the 2 stays there, so it becomes that. Number 6, write the square root as a power. I think most of you knew what to do here, but just mistakes were made. It's a product, so you need the product rule. Left, d right. There's the right function. I will need the chain rule for that. There's an inside function that's not just an x, it's a 1 minus x to the 4th. Bring the 1/2 down, plug in the inside function. 1/2 minus 1 is -1/2. Don't forget to multiply times the derivative of the inside function, 1 minus x to the 4th, which is -4x cubed. The dot there is essential. Well, okay, if the dot's not there and you have parentheses, it's okay. If just the dot's there, it's okay. But if the parentheses and dot is missing, it's a problem, because then you'd be implying you're subtracting something, but you're not doing that. You're multiplying times the negatives of something. So that's left d right plus right d left. The derivative of x squared is 2x. And here's the right, which we could leave as a square root if we like, or we could write as 1 minus x to the 4th all to the 1/2 power. And by the way, in case you're ever tempted to think right there that you can bring that 1/2 down into each and write this as 1 to the 1/2 minus x to the 4th to the 1/2, don't ever be tempted by that. You cannot do that with a 1/2 power. Not allowed. Final problem, a, b, and c are constants. The inside function is bx plus c. You'll need the chain rule. The a as a multiplier out front just stays as it is. The derivative of sine is cosine. Plug in the inside function. Then finally multiply times the derivative of that inside function with respect to x. The derivative of bx plus c is just b. Done. Okay. Sometimes people just made problems too hard. Okay. You were making some of these problems harder than they are. Understanding concepts clearly, getting enough practice is what can help dispel that. Of course, when you get practice, you want to make sure you're doing it right, which I would encourage you to work together on you practicing, or check things with Mathematica, or if you practice, say, odd problems that you haven't done before, check things in the back of the book.